reason why we're going over area of triangle is because triangles will actually make up all these shapes. So if you forget the equation for area of rhombus or kite, you can always use triangles to figure out area of rhombuses and kites. So area of a triangle would be area equals 1/2 base times height. It's not on the reference sheet, so you do have to have it memorized. This would be the base of a triangle, and then the height is always perpendicular. In a right triangle, this is the base, and then the height is the side because it's already perpendicular. And then another thing is, and you don't have to flip your page, I'm just going to briefly show you, is when we get to shapes like this, you'll actually just use triangles to figure out the area. So like for this, you could break it up into triangles, find the area of each triangle, and then just multiply by however many triangles go all the way around. So that's where the triangles come in. And then area of rhombus, rhombi, and kites, there is an equation. It is area equals diagonal 1 times diagonal 2 divided by 2. So D stands for diagonal. So in these, the rhombus and kite, so what makes a rhombus is all the sides are the same length, and then also the diagonals are perpendicular to each other. This. And it's just like the length of this times this divided by 2. So essentially you're finding the area of all the triangles at once by doing that. And then with a kite, same thing, diagonals, the length of this diagonal times the length of this and divide by 2. And it's just letting you find the area of all the triangles at once. Am I going crazy? No, it's not. Okay. So then number 1 here, it says find the area of the kite or rhombus. So this would be a kite. So area of a kite is diagonal 1 times diagonal 2 divided by 2. So the area here, and it shows that the length of this is 19 times 38, and then divide by 2. So 19 times 38 divided by 2 gives you 361. That making sure the number came out right. Yeah, this came out right. So area equals 361 units squared. I'm copy from earlier. Okay. Okay. Then over here, this time we have to add up the values. So area equals, again, diagonal 1 times diagonal 2 divided by 2. But this time they'll give us each segment individually. So this would be 12. I'm just doing 2 plus 10. So 12. And then the diagonal this way, 6 plus 6 would be 12 as well. So just 12 times 12 divided by 2, 144 divided by 2 would be 72 units squared. And just to show you, like, if you forget this equation or how it works, because again, this equation isn't on any reference sheet, you can always use the triangle. So like the area of this triangle would just be 6 times 10 divided by 2, so that would be 30. Area of this triangle, 6 times 10 divided by 2 would be 30. Area of this triangle, 2 times 6 would be 12 divided by 2 would be 6 and 6. And then you could add up these values. 30 plus 30 would be 60. 66, 72. So you could do that in a pinch if you needed to. Okay, then number 3, area equals diagonal 1. This one's 14 units, and this diagonal is 10 units. So it'd just be 10 times 14 divided by 2 equals 70. So you get 70 units squared for the area of this. Okay, number 4, they incorporate something else. They don't show you the length of this diagonal. So if this is 6, and then this would have to be 3 and 3. And then we could actually use Pythagorean theorem to find this missing side. Get the phone in a second. So we can do 3 squared plus b squared equals 5 squared to find this missing part, and then we'd have a diagonal. Hello? Yes, it is. Yes. After class is okay? Okay. Okay, thank you. Ruben, after the lesson, you have to go to 13264. Unless, just wait till after the lesson, Ruben. Okay. Ruben, wait. Learn this first. This you can come after class. Okay. So then finding this, you just solve for b squared equals 16, square root, b equals 4. So this length here is 4, which means that this would be 4. And now this diagonal is 8. And then from here to find the area of the whole thing, diagonal 1, 8, diagonal 2 is 6, divided by 2, 48 divided by 2, which is 24 units squared. By the way, it doesn't matter which one you designate as diagonal 1 and diagonal 2 because you're multiplying, like you can multiply in any order, so it doesn't matter. Okay, then all the homework questions, by the way, will look like this. So we're going to build into some higher concepts and some vocabulary, but just know like the homework stays at this level. Okay, so here it brings in some vocabulary. It says identify the center of polygon JKLMN. So JKLMN is the like pentagon in here. The center is point P. Okay, and then 6, identify the central angle of the polygon. So what a central angle is, just to review the vocabulary from the beginning, is like when you have an angle from the center to the vertexes like this. So the central angle here would be NPM, angle NPM. Okay, and next it says, what is the radius of the polygon? So radius of a polygon goes from the center to a vertex. So center to vertex. And so looking at this, I would say NP or PN and MP. So NP and MP. And the length of that, it says is 5 if they were looking for a number. And then the next word we haven't seen before, it says, what is the apothem? So what apothem is a segment that goes from the center to the side, and it's like perpendicular to the side. So it goes from the center to the side of the polygon. It's the shortest distance, of course, and it's perpendicular to that side. So looking for an apothem, it would be right here, PQ. And it says that that length is 4.05. Okay, then down here, find the measure of a central angle of a regular polygon with the given number of sides. So to find the central angle of a regular polygon, all the sides are equal in length and everything. So we can just take 360 degrees and divide by the number of sides, and it gives us each central angle. So like 360 divided by 18 equals 20 degrees for each central angle, or 360 degrees divided by 24 gives us 15 degrees. Sometimes that degrees is a decimal, and that's okay. Divide by 7, and it comes out to 51.4 degrees. And then we'll flip to the back. We're not doing everything on the back, just some of it. Okay, so this, again, continuing to build concepts about these polygons. It says find the given angle measure for the regular octagon. So octagon is 8 sides. Regular means that it's all equal, like all the sides are equal, all the angles are equal. Okay, so first things first, it wants the measure of JGH, or GJH, is it GJH? And just connect the dots in that order. So with this being a regular octagon, this would be a central angle, and to find that angle measure, we just do 360 divided by 8, and it comes out to 45 degrees. So this angle right here, 45 degrees. Okay, number 14, what is the measure of GJK? So GJK would be this angle right here. So that would be just half of 45. So 45 divided by 2 would be 22.5. Then next, it wants the measure of KGJ. KGJ, so this angle right here. So what I'm going to do is I'm going to take this and just draw it a little bit bigger over here. And we found that this angle right here is 22.5 degrees. This, of course, would be 90 degrees. And then it wants us to find this angle right here. So the way we would find this angle is 180 minus 90 minus 22.5, and that would give us this angle, which is 67.5 degrees. And last but not least, measure of EJH. EJH is this. It's 1, 2, 3 segments or parts of the octagon. So we can do 3 times 45 degrees and gets 135 degrees for that angle. Okay, so these exercises is really where it starts building the higher level. I'm not going to go too high, but I don't want to leave it out either. Okay, so 17, it wants to find the area of this polygon. It calls it a regular polygon, meaning all the sides are the same length and all the angles are the same. For a triangle, area equals 1/2 base times height, right? So it seems like it would be easy, but they don't give us the height. We just have bases. So what we're going to do instead is break it up into 3 different triangles. And then we have the base and height of this triangle, which we can find the area of this and then multiply it by 3. So area of like one triangle, and I'll just make a little note that's just 1/2. The base would be 12, and then the height 2 square root of 3. Then in the calculator, however you want to, square root of 3 times 2 times 12 times 1/2, or divide by 2, and I get 20.78. So the area of one triangle is 20.78 units squared, but I have 3 of them. So the area of all will be 3 times 20.78. So area of all will be 62.35 is what it comes out to. 62.35 units squared. Again, just building different concepts here. We're not going to go through and solve it all because it's a lot of calculating. We're running out of time. But for like 18, break it up into triangles and then just draw a right triangle. And so this little right triangle here would be like 10 and 3.42. And then you could use Pythagorean theorem to find the height of the triangle. And then you could use that to find the area of that triangle and then multiply it by however many triangles there are. Same with number 19, you could use Pythagorean theorem to find this length. and then use that to find the area of this triangle, and so on. And yeah, and then on the ones on Alex, what's nice is they give you a lot more numbers than they're giving you here. So for example, they might say this is 5 and this is 3. So you just find the area of that triangle, 5 times 3. So if you have a 15, 7.5 units squared, and then you can multiply that by 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. You could multiply that by 6 triangles and get the whole area of that shape. So like on Alex, that's how you would do it. It's a little bit easier. But yeah, that is all. So your to-do list is homework 11-3 on Schoology, work on your weekly Alex, and let me know if you have questions. So go ahead and grab a laptop, get logged on. I don't know why my touch screen like stops working sometimes. Yes, ma'am.